Hello again, and in this video we're going to look at the bike problem. The bike problem is a nice problem because it's a combination of everything from the angular linear speed, including that last one we talked about, the omega 1 R1 equals omega 2 R2 formula. Now, if you're following along in the handout, it's number 3, it's the last page, page 7 of 7. And it says a cyclist is traveling 25 miles per hour on a bike with 13-inch radius tires. The gear of the rear tire has a radius of 0.75 inches, while the front gear has a radius of 4.5 inches. Basically, what I'm going to ask you to do is find out how fast the cyclist is pedaling. Now, in order to do that, I want you to follow a 3-step, very concrete process here. If you're given how fast the bike is moving and you're finding out how fast the person is pedaling, the very first thing you have to do is convert the linear speed of the bike. Notice I put V sub t, t meaning tire, so you can use all the tires information. Secondly, we're going to find the angular speed of the tire. And third, we're going to use that angular speed in the omega 1 R1 equals omega 2 R2 formula. Now you may be asking yourself, well, why am I using the tire's angular speed? Well, the tire and the rear gear are spinning in unison. And that's the whole idea behind it, is that no matter what gear you're on, that gear and the tire share the same angular speed. So once you have the angular speed of the tire, that automatically becomes the angular speed of this rear gear. So that's our general 3 steps. Let's get a little more specific. First, label our information. I'll let R1 be the radius of the front gear. Think about it. This is where you're pedaling. This is the rear tire. Your front tire would be up here. So the person's sitting right above this front gear. So R1 is 4.5 inches. R2 is 0.75 inches. The radius of the tire is 13 inches. And the linear speed of the tire, and we say the linear speed of the tire because the tire is what's in contact with the road, not the gears. So the linear speed of the tire is 25 miles per hour. First thing we have to do is we have to take that 25 miles per hour and convert it. Now what are we going to convert it to? Well, all of our radii are in inches, so we know we have to convert the miles to inches. And I'm asking for the end answer to be in RPMs. So that's revolutions per minute. So we have to convert our hours to minutes. So linear speed is 25 miles per 1 hour, 63,360 inches in a mile. And again, miles are on top here, so they have to be on bottom in order to convert. Converting those to inches. Hours down bottom here, so they have to go up top, converting those hours to minutes. So your miles cancel out, hours cancel out. You take your 25 times 63,360 divided by 60, you should end up with 26,400 inches per minute. Now, step 1 is done. Step 2 is we're going to use that converted linear speed to plug into our angular speed formula, just like we did previously. We had the 2 steps when solving for angular speed given linear speed and radius. We had to first convert, and then second plug into the formula. First step we converted, second step we're plugging into the formula. Same thing. So our linear speed of the tire converted is 26,400 inches per minute. That's all divided by our 6.28 times R. In this case, we're using the tire's radius of 13 inches. Not any of the gear's radii, but rather the tire's radius. Keep in mind, put that denominator in parentheses. So you take your 26,400 divided by, open parenthesis on the calculator, 6.28 times 13. Close it, hit enter. You should end up with 323.37 revs per minute. Now that's how fast the rear tire is spinning. But keep in mind, that's also how fast the rear gear is spinning at the same time. So not only is this the angular speed of the tire, it's also the angular speed of, oops, that's not an omega. It's also the angular speed of the rear gear, or omega 2. So now when we go to the third step, which is the omega 1 R1 equals omega 2 R2 formula, the R's are the 2 gears radii, R1 and R2. We know the angular speed of the rear gear, omega 2, so we end up solving for the angular speed of the front gear, which is omega 1, which is how fast the person is pedaling. So we go to our formula, omega 1 R1 equals omega 2 R2. Omega 1 we do not know, but we know R1 is 4.5 inches. Omega 2 we calculated to be 323.37 revs per minute, and R2 is 0.75 inches. So basically you're going to multiply these two and then divide by your 4.5, which is what I have here. You should end up with approximately 53.9 revs per minute. So that's how fast that person is pedaling. So in review here, if you're given, and you're going to have a problem in reverse like this as well, if you're given how fast the bike is moving and you have to find out how fast the person is pedaling, you first convert your linear speed, plug it in to find the angular speed of the bike, which is also the angular speed of the rear gear, and use that angular speed with the 2 gears radii to solve for the angular speed of the front gear. Now, you're also going to have problems where you're given how fast a person is pedaling, and you have to find out how fast the bike is moving. If that's the case, in other words, if given the pedaling speed, and you have to find out the linear speed of the bike, or v, you're going to do these same 3 steps but in reverse. The first step for this would be the last step here, which would be your omega 1 r1 equals omega 2 r2 formula. Because you have given the angular speed of the front gear, which is how fast a person's pedaling. You'll be given the 2 gears radii, and you have to solve for the angular speed of the rear gear. Once you have that, your second step will be the same here, only instead of solving for the angular speed, you'll be solving for the linear speed. So you'll be using the v equals 6.28 omega r formula, using the omega that you use there in that formula with the radius of the tire, because you'll be looking for the linear speed of the tire. And third, most likely you have to do a conversion, because I'll probably ask for it in miles per hour, and you would simply be converting the linear speed of the tire, which was the first step that we had here. So again, if you're given how fast it's moving, automatically you have to convert that linear speed. If you're solving for it, that's going to be the last thing you do here. So these bike problems, there's only 3 major steps. But if you follow this format, you should be fine.